Okay, so
I don't even know what I'd do.
find a
I have it
space.
first.
All right, guys. So as Ray was saying, for the limit to exist, as you come up on the left and the right of that x value at 2, is it going to the same place? This one, yes. Right here, it's going to 2. Even though it's defined as, Tessie was asking, it's defined somewhere else. The limit is not 1. The function itself, f of 2, is 1. The limit is 2. Does the limit at 3 exist?
Yes.
Yes, because the limit from the left and the right and the function at that point, it's 5.
There's both sides of the bridge are there and the bridge is there.
Both sides of the bridge are there and the drawbridge is closed. You can drive over it. Yeah. Down here, does the limit exist at 4? From the left, it goes to a little bit less than 2, and from the right, it goes to 4. You cannot drive over that bridge. If you close the drawbridge, you did not good. So this one is not true. Read the questions carefully. Which one's false, Carson?
The one that's circled.
Nah. So you get this question. What's that?
All right.
How do I do that?
So you'd find the potential points of inflection.
What are the potential points of inflection?
0, 3, and 6. So you
And
do
how
a
did,
little graph.
So a potential point of inflection is where the second derivative is 0. So we took each of those factors, okay, and then you said do what with them?
Put them on the graph.
On a number line.
Number line effect. And then you plug in points in between and around those to find if it's negative or positive.
Okay, so putting in like negative 1,000,000, that's always going to be positive. Then negative times negative.
Positive.
Putting in 2,
Positive.
negative times negative is still positive. Putting in like 4,
Negative.
positive, negative. Putting in 5,000.
So it would be 3 and 6 because the change is sign.
Okay, so hang on. So to finish, what the definition of an inflection point is, it's where the second derivative is 0 or undefined, and it needs the condition that it changes sign. That's why you put it on a number line and tested the regions. And I actually gave this question to a pre-calc kid, and they were like, I don't know what that thing is, but if you need the sign to change, I'm not even going to check this because I know it's not going to change because there's a squared. That makes it hiccup. Or if I slap an absolute value bar on it, that's going to make it hiccup. Yes.
My question was based on the fact that a square always do we know that whatever is like in the x minus 3 or x minus 6, that's always going to be a point of inflection? Can we like make that assumption?
I would not make any assumptions.
This
is AP, don't do that. I would test them. And if you get it, if you get that they're all positive, maybe go back and double check something because you probably did some arithmetic wrong, but definitely always check. Other questions on one of these two? Okay. And now the third one, which is off the screen. Isaiah, oh my. How do I do that?
First, do the derivative of f of x.
Okay. How do I do the derivative of f of x?
2x plus 2.
Okay.
And then like substituting natural log of x. Well, no, you have to chain rule it. That's fine.
How do I?
So you do the derivative of natural log of x.
Okay, you said you got to chain rule it. If I was to do the derivative of this, derivative of the outside, leave the inside alone, and then chain rule, which the derivative of natural log of x is. Okay, I agree that this is what we wanted. Hold on. So you found f prime of x, so that's f prime of natural log of x. So it's 2 natural log of x plus 2 chain rule? Is that question, is that answer anywhere on here looking differently? Where? Okay. Tamar? Why do we have to use chain rule? Because there's two functions. Okay,
Oh, damn.
this said f of another function. It's not f of 2, it's f of some other function. So this is one way to have done that. Some people did this differently yesterday, and they said, I am going to find the function with ln x in it. Okay, so I'm just going to find f of natural log of x. Then it said, do the derivative of that. Okay. The derivative of that, multiply the power.
Can I close your door?
Yep. Lower the power, and then chain rule, multiply by the derivative of that natural log of x. And then the derivative of this. All right, that doesn't look like any of these answers. Well, it looks kind of like this one, but this one doesn't have the x in the denominator. So this is 2 natural log of x plus 2. That's an over x, that's an over x. I still get a.
So would you recommend the first one?
I recommend whichever one works for you.
Okay.
There,
The first one.
it depends on, for me personally, it depends on what these functions look like, whether one is easier than the other. But it's kind of like if there's high humidity, I'm going to do this one. If it's, raining out, full on raining, I'm going to do the other one.
That's the same thing. High humidity.
No, high humidity and actual rain, different.
Wait, so if we're doing the derivative
Don't
of
argue.
2 ln x, just treating ln x like a variable.
I was doing the derivative of natural log squared. The derivative of stuff squared, multiplied by the power, that's where the 2 came from, lower the power, natural log to the first, and then chain rule, derivative of natural log of x is 1 over x. Yeah?
The second part, the 2
Then that's like 2 times x. Well, the derivative of 2 times x is 2 times, multiplied by the power, lower the power, just 2 times 1. Well, this was 2 times, what's the derivative of natural log? 1 over stuff. Yes? So that was yesterday's exit card. Woot, yay, raw. Yeah. Okay. Midterm is tomorrow.
No, that's not yet.
Say it like you mean it. Woo! Woo! Okay.
Like,
Scantron. Yes. It is
You're
my
happy about that?
favorite day.
Yes, to see
And-
kids suffer.
Mine too.
And you don't have to agree.
Okay. And there are 4 forms. 1, 2, 3, and 4. And I have already written your name on the Scantron so that, like, first of all, I'm going to put you in some kind of alphabetical order because none of y'all sitting where your actual, like, seat is. So, sort of, but there's like 10 of the 30 of you kind of jockey around like, well, they're not here yet. So I'm sitting here. I don't know who that is, Eric. So mainly because when you don't actually put the form number on the thing, I can go back and be like, Carson had form 3.
Wait, the test?
So it's Scantron. I can I put your name on the Scantron already, so that
But you're saying there's 4 different tests.
there's 4 different, and I have 4 different keys to run them through. But if you don't tell me that yours is form 1, 2, 3, or 4, there's a problem.
You already put our name on the Scantron. You might as well just sign us.
What if you
So I don't know which form you're gonna get.
well, then she can probably go like, oh, well.
Okay.
this seems like it.
Anyway, so I will interrupt you, and I apologize now for interrupting you, but I will stop by and be like, you put the form number on the damn Scantron, and
I will
some
try my best.
one will not. And I will endeavor to fix it, but if I can't figure it out, I'm gonna just shove any answer key through there. But like, I don't know.
Well, why don't you try all 4 and see which one goes higher?
Okay,
You just shouldn't like test any of ours against a set answer key. It should just be like whichever one is highest.
right, I'm gonna run it 4 times, sure.
Tomorrow's a great point there.
This is kind of fun.
Okay,
No, because you just like, so it's x cubed, right? And then
So
you derivative
f of x is
squared.
blue.
Alright.
X.
Wait, I know
It's
this.
kind of fun. It's kind of fun.
Eric, what are you saying? What's the relationship? Who's the function? Who's the first derivative? Who's the
I think it's blue, orange, red.
blue is function?
Mhm.
Ooh. And then you said orange is F prime and red is double prime. Natalie, why do you think that might be right? Or do you disagree?
No, I completely agree. I'd say one, you can just do it because they generally get less complex if you go around. But also, if you look at it like the mathy way, you're gonna get red is it's a positive slope, and red would be concavity. And if you look at the orange one, that's concave up, so it would make sense for red to be positive there. And then if you look at blue, it's just blue.
Okay,
That's how it
So-
makes sense.
Tessie, what would you say?
Wait, well, could we do like least to most x-intercepts?
You can do whatever you want. So what are you saying? Like, you're saying,
As you take the derivative, the, what's it called, degree decreases, so that's fewer x-intercepts for the more derivative.
so,
I appreciate
like,
that.
all right, so Maya, just a second, I'll ask you in a second. But what Eric would seem to be saying, well, it kind of looks like we were doing power rule, and Tessie, you just said that too. If the blue is the function, that blue thing is some kind of x cubed. And the derivative of that looks like some kind of quadratic, some kind of squared thing. And then the derivative of that is some kind of straight line. Maya, what were you going to say?
Just looking at all of the important, like, critical or whatever. So at the maximum, we have it going from increasing to decreasing, and we see that graph going from positive to negative. At that point, we see the red going from negative to positive, like having a negative y to positive y, and we see a shift in concavity in the blue.
Okay, so he said on the function, that the thing that he sees as the function, there's a horizontal tangent here. So the derivative will be 0 there. Is there some other function that hit 0? Yeah. And let's just double check, make sure. This guy had a 0 horizontal, and that guy has a 0 there. And then he said the slope from this to that is negative. So the derivative needed to have a negative value. So we get that. And then reasoning the orange one, well, the orange one has a 0 horizontal there, 0 slope, and its derivative crossed 0 there. The orange one had a negative slope, so this was negative. Like, yes, there's lots of ways to reason through this, and whichever one works for you, go for it. Yes. So you guys should have the packet out and a notebook. And what other, like, this was just paging through. What other questions do you guys have? Yeah.
10.
10.
13 after that. 13 and 14. Did we actually?
Okay. 10. Linearization. What does linearization mean? Make it a line. Lineify. Make it a tangent line. So, linification. It's not a real word.
Well, there's
No, but I can verbify anything I want. Take back English.
Or number 10, how do you do the natural log of 4 without a calculator?
You don't.
So we use a calculator?
Nope.
a calculator on the test?
Nope.
Then how do we do it?
How did you do this one without a calculator?
Leave it as natural log of 4. Okay,
I don't
guys.
like that.
So how do you get the linearization? You find a point and a slope. What is the coordinate at 1? Well, plug in f of 1. So you're right, that's natural log of 4. What is that? I don't know, something bigger than 1.
Hopefully.
More than hopefully, it's actually a little bit bigger than 1. How do I find the slope? Well, I'm going to do the derivative. The derivative of natural log of stuff is 1 over stuff times the derivative of stuff. That slope evaluated where I wanted my coordinate, well, f prime of 1, plugging all that in, I get 3/2. So the tangent line, y minus the y value equals slope times x minus the x value, and leave it. Like, don't distribute, don't simplify, just stop. And if it's in multiple choice form and it's got the y equals and you had to move things over, okay, you might need to clean stuff up a little.
So linearization is just.
Linearization is a pain in the butt way to say find the tangent line.
So again, that's
So hang on, so that was part A. Part B says now use your thing to approximate the value when x is 1.2. Okay, so that means solving for y, plug in 1.2, and this was then a calculator question. Like,
Can you
So we won't have.
go back to how we found the slope?
do the derivative. Derivative of natural log of 3x squared plus 1 is 1 over 3x squared plus 1, then times the derivative of that stuff, which is 6x. And then the derivative evaluated at 1, plug in that 1. But the question of use your linearization to find. I can ask questions like this that don't require the calculator. Or I could leave the answer as 1.2 minus 1 is 0.2. What is 0.2 as a fraction? 1/5. It's 2/10, right? Which reduces to 1/5. So
But B and C were both. So like, because you were, when I tried to find, I mean, I guess obviously I didn't, but when you try and find it's an over or under, you need to, especially with the
Okay.
natural log, you gotta plug it back in, so.
So is it an over-under approximation? We need to know if it's concave up or concave down. So doing the double derivative, and at 1.2, the whole thing, I wouldn't ask anything that
You
mean.
didn't necessarily need, okay.
But really, we're gonna test at where we did the line. We're gonna plug it in at a 1, not a 1.2. And that's 24 minus 36, that's a negative. So you should test it at where you found the tangent line, not where you did your approximation. Yeah. Natalie.
You totally explained this already, but I forget. What's a normal line again?
Anybody remember? Physics people? Simon? I'm sorry, you.
Is orthogonal to the tangent line, right?
Holy crap, what the hell's orthogonal mean?
Right angle.
Right angle.
What?
Okay.
So, all right,
Oh, it's.
Say what?
in physics, there's a tangent line which is something that touches and comes out.
Yeah.
The normal line is perpendicular to that.
Okay.
So in physics, the normal force is what keeps you pulled back on the curve. And in geometry, we use the word orthogonal and perpendicular. They all mean they make a 90-degree angle. Unless you're in conical space and then it does something.
Wait, what does it do?
Depends on the angle of your cone.
So general question, how good should we be on the derivatives of like arcsecant?
Arcsecant would be a mean one, but derivative of
You're pretty mean.
arctan,
What is that?
I am mean. Dang.
It's crazy, is that?
I have warned you guys that the AP exam is obsessed with tangent and arctangent because the graph of arctangent, has this cool thing that it has two naturally occurring horizontal asymptotes, which are just crazy. And what is the derivative of arctangent?
1/1 plus x squared times dx.
Okay, so if and he added that times dx, because if this was, arctan of 3x, he would have said 1/1 plus 3x, the whole thing squared, times the derivative of that 3x, which is tres. AP exam loves arctan. Know that one. Whether for tomorrow's test or not, know that one. For May, they love it. For life, as long as life involves doing some calculus. Yeah, it does here, it does right now. No, the trip to Hawaii was traded entities. It was just pre-calc. I didn't even know.
It was technically. Not.
Was it in the first 3 chapters of the textbook?
It was log, cosines, and sines. Yes.
Just that.
Well, knowing a lot of trade. Doing really fancy trade to make big calculations of mapping the warped stars onto a flat map more accurately. Yes.
Wait, so you did Mercator but better?
I did Mercator for stars.
What's Marcator?
How long was I in
Mercator is a projection
Hawaii?
layer.
10 days?
Did you get to relax?
Yeah. I had to carry the luggage. That's all I had to do.
Right.
Woo!
You didn't have to do any math?
No. I didn't write the paper. They needed help taking stuff. So I helped with solving the problems.
So they paid an extra $1,000 for plane tickets for
There
someone to
was
help carry
stuff.
Oh,
That was great.
they couldn't make it
I didn't have to go to the conference. I didn't have to do anything.
They can have a person take a second trip.
She goes through.
Yeah, that's me. Thanks for the vote of confidence, everybody. So it was 10, then 11?
That's 11.
Oh, wow. What?
Is that a circle?
Is that a circle?
I can't tell.
No.
What's the point of those?
What's the equation of a circle? Carson, that was you.
Ooh,
Ooh.
x squared plus y squared equals something. R squared.
Equals something.
Oh.
So, yeah, that's a circle. When did they teach you this? Supposedly in geometry these days. It used to be in Algebra 2 and then more so in pre-cal, and then they just kind of destroyed it altogether.
So none of us know it.
All right, but this one, how do I do that derivative?
Wait,
use product rule in the middle.
Gotta do product rule somewhere. Liv, what do I do?
Well, you gotta make the y. You gotta.
I can't solve for y. I can't pull it out. It just
Implicit differentiation.
implicit differentiation. Oh my goodness.
Yeah.
Francis, how do I do the implicit differentiation? I sound so smart. Shut up with the laughing at me.
Sorry. Seriously, guys, shut up.
Okay, so the derivative of x squared with respect to x is 2x. These guys, the collective, said, then you got to do product rule with that thing in the middle. The derivative of x, the first times the derivative of the second, the derivative of y with respect to x is just dy dx. I don't know. It's how does y change with respect to x? Well, that is this symbol. And then plus the second times the derivative of the first with respect to x. How does x changing with respect to x? That's dx dx. So what's the derivative of y squared?
We went through right here.
All of that one.
Okay, Miles, Miles.
Whoa.
Mael. What? I could write dx dx, but it is just one. It's going to cloud things up, so I'm not going to write it. And then, Brooke, what's the derivative of the constant 27? 0. Okay. And then it's just a matter of move things around so you get dy dx by itself.
Right.
Mikhail, how do I do that? Here it is so far. How do I finish? I did all the calculus, you just got to do the algebra. Okay,
Like divide.
by dividing. Nope. Keith? So move the 2x and the y to the other side, so these guys go away. Then I have those two guys with dy dx on them. And then, now that it's factored out, whew, that's some business.
I should remember that. It's crazy.
My out?
So, I feel like I remember asking this when we were learning this. What's the point of adding dy dx to last?
Oh, where did you get that 2 from?
What's the point of,
Adding it to 2y.
oh, so this was saying multiply by the power, lower the power, and then the derivative of the stuff inside.
Oh, that's a y. Okay.
How would I write the derivative of this? What's on the other side?
Y prime, dy, over d.
So when you do the derivative of y, you say y prime. Well, what is y prime if I spell it out in its full name, first and last name? Dy dx. The derivative of y is dy dx. You just did it. So right here, when we did the derivative of y squared, multiply by the power, lower the power, and then do the derivative of the stuff inside, the stuff inside was y. What did you just tell me is the derivative of y? You told me it is dy dx. That's why it's there.
So there's like an invisible dx over dx next to 2x.
It's not invisible. It reduces to 1, so I just...
Right, but, okay.
Tamar? Okay, product rule. Product rule, I'm going to get 2 pieces. This became both of these things. First times the derivative of the second, plus the second times the derivative of the first. Isaiah?
Is dx like constant? Oh, it's not right.
Oh, it's not constant at all.
Okay.
I mean, it can be. It is, what is the slope? How is things changing? If I have a horizontal line, what's the slope? 0, it's not changing. But if that's your slope, what is dy dx? Well, are you on this part of the hill? Are you on that part of the hill? It's not a constant.
So why did dx simplify one, dy dx simplify?
Stuff over exactly the same stuff. Yeah? So that's a 1. But dy over dx, how is the y value changing as x changes? I don't know. Where are you? What are you doing? Like, okay. I'm not sure it's a good idea to do part B and C on this. You actually want to know?
Will it be on the test?
Could be. I don't know. It's been
What do you mean?
You don't
No.
know.
See, you say it's not a good idea, but
Okay,
Then
so
it will be
Just
like
on to 12.
close to the test.
This is
Again-
also, this is what you said.
Questions
We were like,
1
do you
through
guys want to do these
24.
questions? And then
In-
after class, was like, you guys should have done the questions. I
In-
said it was the whole exit card.
in 2 weeks, I have done 30 exit cards, 5 different midterms in 3 different preps, and 3 different reviews. So I have no idea what's on anything. So,
okay, I'm just gonna say this isn't on the test and we'll just move on.
like, so what would you have to check? Like, this would be on the free response. And there used to be a multiple choice and a free response. This would be a kind of free response thing. But just to ask real quick, where the slope, where is the tangent horizontal when the slope is 0? When is the slope 0 is when the numerator is 0.
So
When does it have a vertical tangent is when the denominator is 0. That is a concept that you guys should know. Yes?
could we just say when negative 2x minus y equals 0, or are there more fancy
Okay.
steps you gotta do that?
Concept
Alright.
is
We're doing it.
No.
Hold up, it's not that bad. Can you guys look up though? It's gonna have a horizontal tangent when the top of that slope that we just calculated is 0, which is when y equals negative 2x. You ready for the catch? That's not the end of it. Eric, you had said, that's all, right?
When the top is 0, it's a horizontal tangent,
Yep.
right?
So when does y equal negative 2x?
What is this? When did we do this?
Do we have to find the y values too?
You mean, do you have to multiply by negative 2? Is that a stretch? After all this, your thing is, do I have to multiply by negative 2?
Wait, we plug it into.
Am I mean to laugh?
Wait, where are we plugging that x value into? The original
Okay.
or derived?
Guys,
Oh, yeah, that's actually a good question.
so this is where the voodoo happens. All right. So the slope, where was the slope 0? Slope is 0 when the top of that fraction that we got was 0. That happens when this is true. Go back to the original equation for the whole blasted function right here. So I'm going to swap
So we're
out
plugging
y
this into
and put
f
in,
of x, not f prime of
I'm
x.
swapping out y and putting in that negative 2x. So when x is positive 3 and when x is negative 3, there you go.
Oh, I forgot.
That alarm makes me.
X squared.
Heart skips a beat.
You jumped this time too.
Not entirely sure.
No, I told me, no, I will fall.
It's my wife.
She's gray. So when I say f, top equals 0, horizontal,